Hello, everyone, and everyone joining us today, and welcome to our Physics in the Spotlight digital event. It's kindly funded by the Ogden Trust, and we're really celebrating British Science Week this week. Today's sessions offer a great learning opportunity for you to understand about different careers in physics. We have called this particular session Physics to Infinity and Beyond. The UK space sector is growing, and in this session, we're going to be meeting experts using their physics knowledge in this exciting field and find out about how your future career could be here too. During the session, please do pop your questions in the chat, and perhaps you can mention some space jobs that you know of. Do you know of any? My name is Rachel. I'm from Founders for Schools, and I'm going to be hosting this session today. We hope the session today will help you make informed decisions about your career pathway. To the audience at home, everyone listening in, please make sure that your video and your audio are off. We will ask you questions. You can see that there is a poll here. There will be other questions during the chat. Please pop your questions into the chat function as well. We are recording the session and it will be featured on our Founders for School platform and also on our YouTube channel. So sit back and enjoy the presentations. Please make some notes and think about the questions that you want to answer. So first of all, thank you very much for all of our speakers for joining us today and for agreeing to share your story. And we're really looking forward to hearing all about you. So I'm first going to go to Ellie. Ellie is a science communicator at the Kielder Observatory in Northumberland, and she's going to talk to us about her career journey. Thank you, Ellie.
Hello. So I'm just going to put some slides on so everyone can see this. Is that good?
I can see that, Ellie. That's really good. Thank you.
Lovely. So yeah, my name is Ellie and I'm a science communicator at Kielder Observatory. As well as being a science communicator, I'm also the science lead there, which means that I run all of the projects that we do. So we do a number of projects with schools and universities featuring astronomy, really. That's what we're all about at Kielder Observatory. And as you said, we're based in Northumberland and we are pretty much in the middle of nowhere. So in terms of where we are located on a map, we are just about here. So we are just to the north of England, right on the border with Scotland, about 5 miles away, in the middle of a forest and on top of a hill. So being in the middle of a forest and being on top of a hill, that is how we can see the stars. And that is what astronomy is all about. That is what observing is about. It gives us the best opportunity to look at the sky. So this is a picture of our observatory. And we've got two turrets that you can see that are open there. So those are the two sort of open spaces. And inside those turrets, we've got telescopes. And the telescopes help us to see stars. There's a lot of stars to be seen up in the sky. And as a science communicator, it's my job to introduce people to them. As well as introducing people to the stars, I introduce them to telescopes and what telescopes do. So sometimes this is optical telescopes, like the one in the picture here, so the type that you just look through and see things. And sometimes it can be radio telescopes. So as science lead, I've been overseeing the radio telescope at Kielder Observatory. And what this does is it looks at a different type of light. It looks at radio waves, and these are emitted by objects that usually we don't get to see very well. So things that are very far away, like distant galaxies and things like black holes sometimes too. So my job really is to explain that to people. That's what communication is all about. And so getting to my job, I studied maths and physics at university. So I come from a fairly traditional background in science communication. But in general, it's a field that's open to pretty much anyone. Only about half of our staff have a formal degree within the subject. Most people just have a passion for astronomy and they know a lot about it, and that's all you really need for it, to be honest.
That's great, Ellie. That sounds really interesting. What kind of subjects did you study when you were at school?
So when I was at school at A level, I studied maths, further maths, physics, and chemistry. And I also did a extra project, so an extended project qualification where I looked at geophysics and in particular how volcanoes work, because volcanoes are very fascinating and that carries over to space as well. So one of the things we can look at in space, for example, is the moon. The moon, it has covered in all of these really vast volcanic plains from volcanic activity that happened millions of years ago. And so that's a topic that I will be actually communicating tonight, since it is a full moon tonight.
Brilliant. The knowledge that you learnt while you were at school and the skills that you learnt there, are they the same as what you use in your sort of day-to-day life now?
A lot of the knowledge that I share is the same, if it's not been updated, that is. But the skills I use are often very different because the skills that I was taught at school were, how to do maths, how to apply physics. Whereas what I do in my day to day is I communicate that, which can be an incredibly difficult thing to do, but it's a very important thing. And so that's something that I've just sort of learnt over time, I would say.
And do you think that the people that you work with and yourself, do you think you would have needed a degree to be able to do your job, or you've got people that have come on different pathways?
We've got a lot of people that have come on very different pathways. Only about half of the science communicators have a degree in the topic. And in fact, both of our directors, neither of them at the moment have a degree within physics or within STEM. So there's a wide range of paths you can take into it. All that's really important is just having passion, really.
Yeah.
Passion to
Did you
communicate it.
always have that passion, Ellie, for astronomy? Where did that come from?
Well, I don't know if I always necessarily did have a passion for STEM at least. I always liked art, I always liked history, and I always liked stories. So particularly things like myths and legends. And the thing is, with astronomy, is when you look up into the stars and you see the constellations, that is their stories, they are stories, their history, their humanity's history in a way. And so that's sort of how I got into it. It was learning to look up and it was sort of learning to appreciate what is there. And then from that, I just wanted to learn more. So once I knew the stars were there, I wanted to know what the stars were. And once I knew what stars were, I wanted to know how they were made. And that's sort of how I got into it myself.
Do you have any favourite aspects of astronomy? Do you have any favourite stars, favourite galaxies, favourite things to look at when you look up there?
Definitely, there is a never-ending list. But my favourite thing in the sky to look at is called the Ring Nebula. So the Ring Nebula, it's got a different name as well because every single thing in the sky has a million names. So we can call it M57 too. And it's a cloud of dust and gas. That's what a nebula is. It's just a cloud of gas out in space. But this particular cloud of gas, once upon a time, looked almost exactly like our sun. So it's the end stage of a star. And when you see it through a telescope, it is just a smoke ring that's suspended in space. So that's probably my favorite thing to look at in the sky. It's like a glimpse into our future.
Amazing. Do you want to talk us through maybe what your job's like on a daily basis? So when you're maybe going into work next week, what your kind of schedule is, and maybe what's your favourite part of your job as well?
So my schedule can be quite interesting. The thing about astronomy, of course, is if you're looking at the stars need to be out. So it's a lot of working at nighttime. So my usual day doesn't really start until about 5 p.m. And so about 5 p.m., that's when I leave to go off to work. And I'll usually be in work until between midnight and 3 a.m., depending on exactly what we're doing that night, exactly how many people we're seeing that evening. So yeah, we'll start quite late, go into work, and the way we do it is we run events. So members of the public book on and they come up and we run shows and we talk about certain topics every evening. So it'll be cosmology sometimes, other times it'll be the moon and just anything that's going on that night. And then yeah, we finish very, very late, but it's fine. It's like a normal 9 to 5, but the 9 and a 5 are the wrong way round. They're sort of the wrong 9 and 5.
And what do you feel about quantum mechanics?
So I fell in love with cosmology because it's it's just big, kind of. I always really enjoyed looking at the big stuff, and cosmology is the big stuff. It's the study of the nature and the origin of the universe. And the universe is a beautiful thing. And so being able to understand even, a fraction of it is sort of what got me so in love with cosmology, and the idea of it. For quantum mechanics, I do actually really enjoy it. So I studied maths and physics at university, and a lot of what you do in quantum mechanics is mostly mathematical. And so I always really enjoyed it personally, but it can feel very counterintuitive when you're studying it. It can be very confusing, and I very much remember that. So it's a begrudging love, that one, perhaps.
Oh, we've got a viewer from India, a quantum physicist from India is watching and asked that last question. So that's really interesting. Do you think there's any kind of gender sort of balance at your work? Do you notice that there are more male or more female colleagues of yours that you work with?
There are generally more male colleagues that I work with. So on the science team, we are quite small, and two of us are female, and everybody else is male at the moment. But within our management team is primarily female, so it does tend to skew a bit more male on the science communication side of things, at least in physics and in maths. And I think that's a bit reflective of what I saw at university as well, because I saw a very similar dynamic at university with more males in my course than females. But it's something that I'm seeing improving, definitely, even now. As I said, all of our management, well, not all of our management, but our CEO and such are female. So it's nice to see that changing.
Did you have any role models as you were going through school, going through maybe university, people you looked up to that helped you sort of on your career path?
Definitely. So, in terms of just general role models, I always really admired Katia Kraft, who was a volcanologist. So, she was a French volcanologist who was just so passionate about her work, but particularly her communication of her work. So, she was interested in hazards and how we treat hazards around volcanic eruptions. And beyond just doing all of the usual samples and everything, she spent a lot of time photographing and videotaping volcanic eruptions and hazards to communicate with communities that are in high risk areas. And she saved potentially, thousands of lives of people who otherwise wouldn't have evacuated from disasters. And I think that's something I always really admired. And unfortunately, she lost her life during a volcanic eruption trying to photograph one of these hazards. So she always really, I felt, was an inspiration. And also Dr. Katie Mack. So she's an astrophysicist, a theoretical astrophysicist, who again does a lot of work within communication in like sort of on the side. And she's recently written a book about cosmology and about the end of the universe. And I found that a very helpful book for trying to think of new ways of describing the inevitable end of the universe to people and make it comforting.
Do you have any sort of a final bit of advice before we move on to our next speaker for any of those students who are at school, they're thinking about what subjects to take and what career paths, just a piece or little snippet of advice for them?
I would say follow your instincts and follow what makes you happy. Because if you're forcing yourself to do something that isn't making you happy or that you know deep down doesn't work for you, I think it's going to be harder to do it. I think you should just sort of follow where your mind's immediately taking you, sort of, and don't overthink things.
Yeah, so really enjoying the subjects you're doing. What do you enjoy? I think if you're thinking about what GCSEs or A levels to take, or even, before that, making decisions, do something that you really enjoy. And what you've just talked about there, Ellie, just sounds really, really interesting. Hopefully you've inspired some of our students to take that kind of same pathway. Thank you very much. And so we're going to move over to our next speaker. We have Isabel, and Isabel is an astronomer at Durham University, and she's going to talk us through her career path. Hi, Isabel.
Hi, thank you for the opportunity of coming to this event. I'm very happy to share a little bit of what I'm working on and how I got to this point in my career. So I'm going to share. Okay, so I am a researcher in the field of astrophysics and cosmology. And broadly speaking, I study how our universe formed. To do this, I use computer simulations of galaxy formation that simulate how structure in the universe evolved from the Big Bang until today. So in particular, I'm focusing on the role of the mysterious dark matter that I'm sure many of you have heard about. So we know that the universe is made of 70% dark energy and 30% ordinary mass. But only 5% of that mass is the ordinary mass, the atoms, or like stars, like us human beings, the stuff that we see and know exists. But then there's this other 24% that is a mass that we cannot see and that we don't really know much about. This is dark matter. So it does not emit light, so we can't use telescopes to look at it. So instead of that, we use the computer simulations. So we can infer what its properties are like just by looking at how dark matter affects gravitationally the galaxies and the structure that is in the universe. So here on the left, you're looking at a box, and it's showing what the universe would look like if we could be very far away from the universe and stare at it from a far distance. And that structures that you're seeing there are made of dark matter. And as time passes, the dark matter, we say, collapses and forms these filamentary structures, this filamentary network. In the nodes of those filaments, you can see that how the colors become brighter. This is because there's more dark matter, there's a higher density of dark matter, and in those nodes is where stars can start forming and give place to galaxies, like the galaxy that we're looking at in the right video. This galaxy here is a big spiral. It's a galaxy similar to the one we live in, the Milky Way. And then you can also see that there are smaller bits that are flying around this big galaxy. Those are also galaxies, but smaller ones, and we call them dwarf galaxies. And those are the ones that I study, that I focus on, because they are like bricks. They're like the building blocks that form bigger structures in the universe. So this is, broadly speaking, what I work on. But how did I become an astrophysicist? So research is an academic career, which means that you have to study a little bit, as you can imagine. But I like to think of it more as learning. More than studying, it's about continuously learning and learning. So I went to school, then to high school, then to university. I did an undergrad in physics, where I studied all sorts of physics. I studied optics, I studied quantum mechanics, I studied algebra and lots of maths. I studied particle physics, so all the types of physics. Then I did a master's. This was 1 year, where I specialized in astrophysics and cosmology. And then I did a PhD, a doctorate in astrophysics. and cosmology. This was 4 years where you don't have exams anymore. This is full research. And then after, when you finish your PhD, you are officially, let's say, considered an independent researcher. And we call this stage a postdoctoral researcher or postdoc, and that's the stage at which I am now. Something nice about this type of academic career that I would like to mention is how we travel the world and we get to know a lot of places for work and for conferences. For example, I am originally from Spain, and I did my undergrad in my hometown, but then I moved to the big city to do my master's and PhD. Then after that, I've been working for 3 years in Canada on Vancouver Island, and now I'm working here in the UK. So you get to move around, and in the meantime, I've been traveling to a lot of places for conferences, to meet people, to do projects together. So in particular now, I am a postdoc at the Institute for Computational Cosmology at Durham University. This is in the northeast of England. I'm showing a little picture of the building where I'm working because I think it's really interesting. It has this very funny architecture and that's very nice. And another thing that's really, I think, nice about this kind of job is that it fosters a very inclusive and diverse environment, working environment, because you're surrounded by people from all over the world with different backgrounds, but we're in the same spot working together with a common goal. And finally, I wanted just to include a few words about why I became an astrophysicist, why I'm pursuing this career. And so the thing is that I really like what I'm studying, what I'm learning. I think it's very interesting. And although this is already a very valid enough reason to pursue this career and to study astrophysics and become an astrophysicist, sometimes I have struggled with thinking that with all these skills that I've learned and all the things that I can do, that I could perhaps be doing something different that could be maybe more useful for society. But then when I'm looking at a starry night sky, that's when I remember why it is important to do this kind of job. Because us human beings, we have this yearn for the transcendental. And it's something that's intrinsic and it's natural to every human being. So asking ourselves questions like, how does our body work? How does the brain work? Or how the universe that we live in came to be, and what is its fate, and what is our role in it? I think these are very important questions and there should be people trying to answer them and pushing forward the limits of humanity's knowledge. So yes, I really encourage everyone to pursue this career because it's very exciting and it's every day is a new thing that you're learning. So yeah, that was all that I wanted to share. Thank you.
Thank you so much, Isabel. It was really interesting. Really interesting. There's lots of things there that I didn't understand myself. Did you always want to study astrophysics? When did you start? Can you remember back to when you started thinking about this as a career, or when you started your kind of interest in these particular subjects?
So I've always been curious for the universe, no? Like planets and galaxies and the Big Bang and all this. But I never, but more than documentaries and stuff like that, I never went much further than that. And during my school years, I wasn't sure what I wanted to become. I didn't know for sure what I wanted to study. I liked sciences, but not only physics. I liked biology, I liked chemistry. And at the same time, I really liked arts. So I really, at the end, I wasn't sure if I wanted to study physics or fine arts. So they're very different things. I guess I pursued physics because I I was very curious. I thought that astrophysics would be something that I would like. And during my year studying physics, it wasn't clear to me either, because as I was mentioning before, when you study in undergrad in physics, there's a lot of physics to study. It's not only astro. In fact, where I studied, there was very few, there was only one astro subject, and that covered very few fields. So I finished my undergrad in physics, and I really didn't know much about astrophysics yet, but I was still very curious, and that's why I decided to do a master's specializing in astro. But I have to say that I was always doubtful of what I was doing, of course. And I think no one is ever 100% sure. Well, I guess some people have a very clear vocation, but most of us, I think it's little by little that we just trust that there's something that we're curious about, and that we think that we are going to like, and that we want to learn more about. And then little by little, we get closer to that goal.
Yeah, I think that's really true. I think there'll be some students here who have no idea what they want to do when they, do the next stage of their studying, whether it's GCSEs, A levels, or they're thinking about what university to go to. And, your example is you didn't know, and you've learned as you've gone through the process. How many years in total is that sort of studying that you've done? So you've done your undergraduate, your master's, PhD. How many years is that?
Okay, so I did 4 years undergrad in physics, 1 master's, 4 PhD, so that's 9. And now I've been a postdoc for 4 years, so I guess that's 13.
So it's a long commitment, isn't it, to learning, which you obviously enjoy.
Yeah, I don't like to think about it as, I've been studying for 10 years, and then it's like it's a very continuous career. It's just continuously learning. At the beginning, you have a lot of exams and stuff like that, and then it's just a different way of learning and studying. No, it's your job. Let's say it that way. No.
Yeah, I think in any career these days, that continuous professional development that all of us have to do as we work through our careers is really evident. I think maybe some young people are not really aware that just doesn't end when you leave school, but yeah. I think when it's something that you are really invested in and you really enjoy, it's not a chore. It's really interesting to learn more. Absolutely. That's brilliant. Thank you so much, Isabel, for talking through your story. I'm sure we'll get some other questions in the chat as we go along into our sort of next talk. Please do, if you're at home, if you've got any questions that have cropped up in your mind as we go through, please just pop those in the chat. And thank you to Isabel.
Thank you.
So our next speaker, we have Joel with us, and Joel is an innovation manager, and he uses his design knowledge to shape the UK space technology innovations. And Joel will talk to you a little bit more about exactly what it is that he does. Thank you, Joel.
Thank you very much. Let me share my slides. Can you see that okay?
That looks great to me.
Excellent. Okay, so hello, my name is Joel Friedman. I'm the Regional Innovation Manager at a company called the Satellite Applications Catapult. The Satellite Applications Catapult is a partly government-funded, not-for-profit technology and innovation organisation working to grow the UK space sector. And I've been working for the Catapult for about 8 years. My job has been to travel the world and help people see how space technology can be used to solve global problems. I've been very lucky to have worked on topics like illegal gold mining, deforestation, disaster response, even how to set up a city on Mars, as well as many other really fascinating topics across a whole range of different sectors, working with governments, NGOs, universities, and other innovation organisations. My role specifically is about design and innovation, and I'll talk a little bit about how I got there here in a moment. But what that means is that I help people come up with new ideas. I conduct research to understand challenges that exist, then bring different groups of people together to think about new solutions using combinations of technologies such as artificial intelligence, robotics, and of course satellites and lots of data. And then I work with them to evolve their ideas into new products or services. I help students who want to turn ideas into a reality, work with entrepreneurs who are starting new businesses, or really big companies who want to develop new products. So when I was at school, I studied maths, physics, art, and drama as my A levels. And it sort of spoke to the fact that I had this quite technical side, but I also had this really creative side. And I wanted to make sure that I had the chance to use both. I found a course called Product Design Engineering that was split between mechanical engineering at the University of Glasgow and product design at the Glasgow School of Art. And for me, it was the sort of perfect mix because I could be creative and learn about the process of coming up with ideas, but I was also learning enough engineering to be able to design things that would really work. After university, my first job was as a design engineer at an industrial lighting company where I designed lights for council flats and prisons. And then I worked in an engineering consultancy building test machinery, including machines for testing ejector seat components. These were really interesting jobs, but for me, they were a little bit too technical. And my attention span actually is quite short. I find I'm a lot better at the beginning of projects, conducting research and helping people come up with ideas than doing lots of the detailed design at the end. When I first heard about the Satellite Applications Catapult, they had a role called Design Thinker, which I'd never heard of, but meant applying what's called design thinking, which is the process a designer uses to understand challenges and come up with solutions. But it wasn't just applying it to one type of product like a light or a machine. It was thinking about how to apply it across a huge range of potential products and services that all use space technology to make the world a better place. I worked as a design thinker for about 4 years, from junior up to senior, and then eventually became the head of design, where I led an awesome team of designers working on all sorts of really cool projects. And eventually I changed roles, and again, this time I moved away from managing the design team into my current role, which is about helping to set up teams all across the UK that can practice good design and innovation to grow their local space sector, still using design thinking and bringing together science and technology to solve big problems. So I've talked a couple of times about design thinking, so I thought I would just talk you briefly through the process using the visualization that I learned at university called the double diamond. Now, in this visualization, the shape of each part represents the type of thinking you're doing. So let's say you start with a project brief, like I want you to design a product that helps prevent illegal logging. The first part would be the discover phase. This is divergent thinking. So you're expanding what you know, learning as much as possible. In this case, maybe as much as you can about illegal logging, where it happens, how people are trying to stop it, what isn't working. You want to talk to lots of people and get lots of insights. Then you move on to the defined stage. Now here you're using convergent thinking. So you're narrowing down using all the information you have to identify where the real problem area is that you can do something about. Maybe with illegal logging, it's the fact that forests are so big that people just don't know where to go to prevent illegal logging. So that's the problem you want to tackle. So at this point, you have defined your problem, and then you can start designing. The next phase is the develop phase. This is again divergent, so it's about having lots and lots of ideas of how you could address any problem. And finally, you move to the deliver phase, where you narrow down your ideas, evaluating them against what you're trying to do, how realistic the solutions are, maybe how much it will cost, until you have one idea that you start to build and test. So while this process might look linear, and by that I mean you just go from one end to the other, the reality is you might actually go back over different parts at different times as you learn different things. And one really important aspect of the process is that it's user-centered. So you make sure that the people you're designing for are included in the process. You talk to them about your ideas, share your thoughts, test out concepts, and use their feedback to create the best version of your product. So the last thing I'd like to do is just give you an example of a project I worked on in Malaysia, and this was helping to tackle a problem of illegal oil dumping in an area called the Malacca Straits, which is one of the busiest shipping trade routes in the world. Many tons of oil are dumped on an annual basis. So I was working with the Malaysian government, different departments such as the police, Coast Guard, Navy, and the Environment Agency. So the first thing we did was to go out and understand as much as we could about how they detect oil now. How do they find spills? How do they mobilize different teams? How do they go about cleaning it up? Then I ran workshops to bring together different organizations and map their processes to see where the pain points were. So where were the bits that were really challenging, the bits that weren't efficient and where people thought things could be improved. I then worked with engineers and scientists and other experts to start coming up with ideas for how the service could work. How could satellites see oil spills from space, and how could that information be shared and engaged with by different departments? And what started as drawings on a wall then moved on to more detailed mock-ups that we could use to test out ideas with some of the end users. We went back out to Malaysia and tested our ideas with people who would be using it, captured feedback, and that helped us to make improvements. And eventually there was a working version of what was called Marine Watch up and running, a service that would never have been developed in this way if we hadn't got all those insights, all that information from those users. And it worked. So on the 2nd of May in 2019, I think while our colleague was eating breakfast, he got a notification from Marine Watch that a potential oil slick had been automatically identified from the latest pass of the satellite off the east coast of Malaysia. And once they'd confirmed it with their experts, they asked our in-country partners to highlight it to the Malaysian marine authorities, since we thought it would hit land 2 days later. The Malaysian authorities sent out 2 vessels equipped with cleanup equipment. They located the oil, deployed booms and dispersants to reduce the impact. And these are the pictures that they sent via WhatsApp on the morning 2 days later. So this warning helped to prevent an estimated £1.2 million worth of damage had that oil hit the coast. And that's just the cleanup cost. That's not taking into account the economic cost, the threat to the livelihood of fishermen, not to mention the impact on the marine life and ecosystem. And so the system was also able to identify the vessel responsible for the spill. So all of the projects that I've been involved in have been quite different, but the constants are making sure that challenges are well understood before you come up with a solution, and making sure not to work alone, as collaboration is much more powerful than isolation. And in the role that I'm in, even though I don't work directly as an engineer, my understanding of physics and engineering means I can understand and work with new technologies and have meaningful conversations with both the technical experts and the non-technical experts, and bring them all together to work creatively to come up with ideas to help make the world a better place. So thank you very much for listening, and I'd be happy to answer any questions.
Amazing. Thank you, Joel, for that. That was really interesting, and looks like you're solving lots of problems that we have in the world in such a unique type of way. I think some of the young people may have not realised what satellites can do and what kind of problems they can solve. When you were at school, so you studied physics and maths and the I think it was drama and product design.
Drama and art.
Drama and art, yeah. So how can you kind of talk us through maybe how you use your physics in your kind of day-to-day life? What kind of things are you using on a sort of regular basis?
Yeah, absolutely. You know, for me, when I was at school, the thing that attracted me to physics was I really wanted to understand how the world works. Why do things behave the way they do, and how does that let us design new bits of technology and new equipment? And that kind of went through into my engineering course as well, which was learning even more about how materials behave, how the world behaves, how technology can be developed. And you know, in my day-to-day life, I'm often looking at the latest technologies, what new capabilities exist, and it's understanding the physics. So understanding a big part of satellites is satellite imagery. So you might look at the satellite image, for example, of the example I gave on oil. Certain wavelengths that are sent from satellites reflect differently off different objects. So oil reflects differently from water, which is why the satellite can see oil on water and detect oil spills. And there's lots of examples like that, where having an appreciation of physics, understanding electromagnetic spectrums, understanding electronics, understanding how solar panels work on satellites, all of these things help me to understand what technology can do, and then think about how that technology could be applied to solve different problems.
Amazing. What was your most favourite project, or the one that you felt was most rewarding, like you've really solved something that means something to you?
Ooh, well, that example that I showed, the oil spill one, I think was for me was a really important project. It's something that could be taken to lots of places. I also worked on a project that was in Colombia, and that I mentioned very briefly, that was tackling illegal gold mining, which happens out in the forests, in the jungle, and it happens by criminal gangs, and they destroy huge parts of rivers, huge parts of forests, and it's really hard for the authorities to know where it is. So, working on technology that can help protect the environment, help protect people's lives as well, is something that was really meaningful to me. And I guess the other one was in the Philippines. It was about satellite communication, and it was helping to put communication. So the Philippines is made up of lots of islands, and they have lots of natural disasters, from monsoons, typhoons, earthquakes, volcanoes. They've got everything. And when one of these happens, if you're on a small island and you lose your communication capability because a phone mast falls down, you can't ask for help. So by putting satellite connectivity in these places, all of a sudden people who maybe wouldn't have had a voice in a disaster are then able to ask for help, to say what's wrong, and to receive the support that they need to save lives.
Amazing. That's just amazing how it all links up. Do you have sort of any sort of lasting advice for any of the young people who are perhaps at school still and wanting to go into the kind of work that you've been doing? What kind of advice would you give them?
I think design as a sector is very broad, but having an understanding of how things work, of technology, gives you a really great advantage in terms of being able to use different bits of technology that are out there to come up with new solutions and new services. So I think that's really important. Having a little bit of technical understanding there goes a really long way. The other thing is, to get into the space sector, there are so many different routes. We've heard about some very different, really fascinating other ways you can get into the space sector from the other speakers, and even through people I work with. Some of them did physics and geography. Some of them did more scientific or less scientific. Some of them looked at communication. Some of them looked at Earth observation. Some of them are focusing on Earth. Some of them are trying to build things in space, factories in space, robots that will mine on the moon. There are so many different paths, but yeah, an understanding of science and understanding of physics gives you a really good platform to go in so many different directions and solve so many different global problems. It doesn't necessarily just mean you will be working on machines. You could be looking at deforestation, trying to end world hunger, trying to explore the universe. So it can really take you in lots of different directions.
Amazing. We've just had a question that we can get in before we finish. Do you have a solution for space junk caused by broken satellites? And could this be your next innovation, Joel?
Yeah, it's absolutely something that we're thinking about. And there's lots of ways you can try and catch space junk as well. And it's a problem that is just going to become increasing in magnitude as more things go up in space. You can try and fire a net at things. You can try and nudge things so that they either go out to space or they fall down and burn up in the atmosphere. So yeah, absolutely. A lot of my job is working with people who have ideas and want to develop them. And there are a few people trying to develop this sort of thing, but maybe it will be one of you who develops a product or service that I can help you take to market or get up into space in the future.
Brilliant. I hope there are some young people out there hoping to solve some of the world's problems at the moment. Absolutely. Thank you very much, Joel. And thank you to all of our speakers, Joel, Isabel and Ellie, for joining us today, and such interesting talks about how they use physics in their careers. Please do pop your answers to the poll that we have on the screen now. I really want to thank all of our students and all of the educators for joining us today, and all of the lovely questions that you've popped in the chat. And if you aren't already following us, join us on Twitter, LinkedIn, Instagram and Facebook. And please continue to share our work with your friends and family. So look out for more events. We have one more today, and you can always arrange your own event by using our website and get somebody to come and speak in your school. So thank you so much to everyone for joining us today, and goodbye.